Okay, I have a simple but powerful effect that anyone can perform right away, and it uses a borrowed deck of cards. Okay? Now for the math nerds out there, this effect is based on the symmetries of a square, or in other words, the dihedral group of order 8. But for all normal people out there, that won't matter to you. But if you'd like to understand the mathematics behind it, just take a look at the description below. Now for this, we need 4 random red cards and 4 random black. So why don't we just see what comes off. Okay, so I need 4. Okay, there's 4 random black. And now we just need red. There we go. Got 4 of those as well. Okay, and then I'm going to assume I have 2 spectators here because I'm going to give them different jobs, even though you could do this with just 1 spectator. So spectator A, let's say on the left, can you decide how to stack these? Left on right? Okay, very good. And then I'm going to go ahead and begin to mix these, but the real mixing will happen by the 2 of you. So spectator B, how would you like these stacked? Right on left? Okay, very good. Let me just show you that the cards are beginning to get mixed. They're not super well mixed, but that's your job in just a second. Okay? So, spectator A, what I'll need you to do is I'm going to leave the room and I'm going to have you perform a shuffle that I'll show you in a second as many times as you like. And I'll do a similar thing for spectator B. I'll show you a different shuffle and you can perform that as many times as you like. But I do need each of you to make note of how many times you applied your assigned shuffle. And then when I come back into the room, give me the total number of shuffles between the 2 of you performed altogether. Okay, so spectator A, first I need to show you what your shuffle is. Okay, so yours is called the mange over under. Okay, so for this, you push the top card into your other hand, and it's called the over-under because this next card goes over, next one goes under, over, under, over, under, over. Okay, so that is the mange over-under, and that is spectator A's shuffle to perform. Spectator B, yours is similar, but it gives a very different ordering of the cards, as anyone can check. It's called the mange under over. Okay, so it begins in a similar way. You push over the top card, but now this next card goes under first, then the next one goes over, under, over, okay, repeatedly. Okay, so you got the over, under, you got the under, over. I'll go ahead and leave the room. So spectator A, perform the over, under as many times as you like. Give the packet to spectator B and they'll perform the under, over, and then call me back into the room and let me know how many shuffles altogether the 2 of you performed. Okay, so you can just set this in front of spectator A as you leave the room. And so let's say spectator A decides to do the mange over under twice. Okay, so they would move the top card into their other hand and then go over under repeatedly. And they said they're going to do it twice, which is fine. Okay, and then they would hand the packet to spectator B, and maybe they decide to perform the under over just once, which is fine. Okay, so they push the top card into their other hand. This card goes under, then over, under, over. Okay, very good. And then when they're done with their shuffling, they call you back in, and you simply just ask them one question. How many shuffles altogether did the 2 of you perform? Well, here it would be 3. 2 for spectator A and 1 for spectator B. So as the performer, all I would do is pick up the packet, and I would Klondike, meaning I would take the top and bottom cards off as 1, a pair on the left, a pair on the right, a pair on the left, the final pair on the right. And then you just emphasize to the spectators that there is no way I could possibly know the ordering of the cards after the 2 of you independently mixed the cards using different shuffles. There's just no way. But nonetheless, let's see if I was able to pull off something very surprising. So let's just take a look at what cards are in pile 1 here. Okay, so we got a black one, a black one. Oh boy, a black one. Oh, check that out. That is extremely unlikely. How in the world? The three of us must be in sync in some psychic sense. Okay, so how does this work? We'll do everything that I explained to you. The only subtlety I need to point out is if the total number of these assigned shuffles the spectators are performing is an even number instead of an odd. In our demonstration, it came out to be 3, which is odd. If it comes out to be like 4 or 2 or 6 or 8, an even number, the only difference for you as the performer at the end, okay, now the packet hasn't been like reconstructed, but I'm going to show you the final steps. So instead of doing this Klondike left-right like I did, the only difference is it's actually easier if it's even, because all you do is you push off the top 2 on the left, the next 2 on the right, the next 2 on the left, the final 2 on the right, and you will perfectly separate the reds from the blacks, guaranteed. Okay, well, thank you for watching, and take a look at other videos on the Absolute Math Magic channel.